So the question here is, does Rolle's theorem apply to this function f of x equals negative 18 over x squared minus 25 on the interval from minus 4 to 4? Now, if we remember here real quickly what Rolle's theorem actually says, it says if your function's continuous on a closed interval and it's differentiable on that open interval, and the starting y value matches the ending y value, then there has to be some number or some value on the interval from a to b such that the derivative there is 0. So you really have these three things: continuity, differentiability, and the beginning y value matching the ending y value. Those are the three criteria to satisfy Rolle's theorem. So let's see if that's true here. First off, I'm automatically a little concerned about the continuity issue because, you know, with this being a rational function, there's definitely a concern that we might have division by 0, which would make the function not continuous. So if we take x squared minus 25 and set it equal to 0, we see where these vertical asymptotes are going to occur. This denominator factors as x plus 5 times x minus 5, and so the two asymptotes would be at negative 5 and 5. But fortunately for us, that falls outside of our window. So if we're only looking minus 4 to 4, and that's really all we care about, that's our a to b, those asymptotes are occurring out here, so I really don't care about those. So is it continuous on minus 4 to 4? Yes, it is. So continuity is a check. Okay, now how about differentiability? Well, I could take the time to go and take this guy's derivative, and you're welcome to do that. You could use the quotient rule, or if you rewrote it, you could use the chain rule if you wanted to. But the point is that we know we could differentiate it. So it is differentiable. It's able to be differentiated using the quotient rule. So that'll work. And that derivative will be continuous on the same interval as well. Lastly, is f of a the same thing as f of b? I don't know yet. Let's find out. We literally need to try f of negative 4 and f of 4, because Rolle's theorem is only applicable if these two quantities match each other. Okay, so f of negative 4, we'd have negative 4 squared is 16. 16 minus 25 is negative 9. Negative 18 divided by negative 9 is positive 2. And because this quantity is squared, we can see that you'd still have 16 minus 25, and then negative 18 divided by negative 9. This would also be 2. So yes, these two match each other as well. So Rolle's theorem is applicable. All right, now, how do we find this x equals c value that satisfies it? Well, for this, I suppose we are going to have to go and differentiate this guy, unfortunately, but that's okay. We can do that. It doesn't really matter how we do this. Like I said earlier, we could either use the chain rule by rewriting this, or we could use the quotient rule right here. I think probably the quicker thing would be just to rewrite it very quickly as negative 18 x squared minus 25 to the negative 1. That's still f. That's not f prime. That's just rewriting f. And then differentiate it using the chain rule. Negative 1 comes down, differentiate the outside, we have an 18 x squared minus 25 to the negative 2, followed by the derivative of the inside, chain rule, so times a 2x. So rewrite it, you have 36x divided by x squared minus 25. Quantity squared, if you move it to the denominator, that negative exponent will turn back positive again if you put it in the denominator. Okay, so the Rolle's theorem guaranteed me, it promised me a place where the derivative would be 0. So if you take this derivative and we set it equal to 0, just basic algebra, we all know that a fraction cannot be 0 unless actually the numerator is 0. The denominator really doesn't have any bearing on a fraction being 0. But if 36x equals 0, that's going to happen when x equals 0 right here. So this would be the value that satisfies Rolle's theorem, and sure enough, notice it is in the interval -4 to 4.